Well, thank you very much, Eli, and I think it's intrinsic to the nature of this kind of situation that everybody's going to feel a bit frustrated at the delights that are kind of laid in front of us, but then snatched away before the person has a chance to get to the end of their argument. But I'm certainly looking forward to reading Eli's paper, and I hope that some of you will get a chance to talk to him in the course of this conference, and that many of us can take some of these issues further, because I think they're really important issues, and the dialogue with philosophy of science is one that it's well worth taking further. So I'll now ask Nadav to come up and maybe introduce yourself briefly, since I haven't been able to introduce you.
Okay, hello, Tashidilek. My name is Nadav. I'm a cognitive neuroscientist from Princeton University, and I'm interested in how animals, and today also artificial agents, learn to achieve goals. So my work is actually inspired by Buddhist philosophy to a large extent, specifically the work of Dharmakirti. So it's a great honor and pleasure to present this work to this esteemed audience. Now, I'm interested in goals because goals are very fundamental in how they shape the way we experience the world. Think, for example, how when we are hungry, we see things around us according to whether or not we can eat them. Can they satisfy our hunger? But if we are cold, we can see the very same things differently, namely according to whether or not they can heat us up, they can satisfy our goal of warming up. In other words, our goals determine what aspects of our experience we pay attention to when we guide our actions and behaviors. Now, to use slightly more scientific or computational terms, we can say that goals shape our state representations. What are state representations? State representations are kind of models that we construct in order to understand and behave effectively in the world. Think, for example, if you want to teach a computer how to play a game like chess or Go, you need to give it a model, a state representation that tells it what is the position of all the pieces on the board, how does each piece move, and so on. But for natural agents, natural organisms like animals or human beings, we don't know what goals they are pursuing. We can pursue a large amount of flexible goals, and we don't know what kind of models, what kind of state representations can enable us to do that. And indeed, evidence from neuroscience is increasingly showing that the way our brains represent the world is highly dependent on the goals that we have. So our brains are very much seeing the world through the goals that we have. But we don't have a good theoretical understanding of how these representations come about. And I think this is an important point to make here about the difference between natural and artificial intelligence, which is relevant to the topic of this conference. And I think that in natural intelligence, like in humans, our cognition is fundamentally shaped by our goals. And based on our goals, we construct concepts, we construct representations that help us to achieve those goals. However, in artificial systems, we first introduce representations. We give them concepts, we give them models, and based on these models, we tell them what goals they need to achieve. So it's like a flipped picture here, but there's a slight point we need to be attentive to, that when we define a representation or a concept and give it to the machine, give it to the artificial agent, we already introduce an implicit goal, because any kind of concept, any kind of representation already has some kind of goal that is it's kind of shaped in order to achieve. And here I think is where the ideas of the great Indian philosopher Dharmakirti can help us understand better how to design more human-like artificial systems, or how to understand our own goal-dependent behavior and intelligence. So Dharmakirti's ideas, at least as how I understand them, through the translation of John Donne, who wrote the excellent book, Foundations of Dharmakirti's Philosophy, he developed a theory of concept formation that can help us understand how cognitive agents form goal-dependent state representations, or these goal-dependent models. And what he said, that the way the mind does this is by ignoring all the goal-irrelevant aspects of our experience. So we construct these conceptual models, these conceptual representations, by ignoring everything that's irrelevant for what we want to achieve. To illustrate this, suppose you want to walk from your home to the nearby park, and there are two ways of getting there. Now, if your goal is just to eventually reach the park, you don't need to worry about distinguishing between these two paths, these two ways of getting there. You can represent them using a single concept or a single state of getting from your home to the park. However, if you also want to get a nice cup of coffee on the way, and only one of these trajectories, one of these paths goes through your favorite cafe, now you need to make a conceptual distinction between path A that achieves your goal of getting coffee and path B that doesn't. So we are trying to model this intuition in the language of computational learning using something we call the perception action cycle. This is a way of describing the interaction or the flow of information between an agent and its environment. We define something we call an experience, which is simply a sequence of actions and observations, actions that the agent is doing, performing on the environment, and observations that it receives back from its environment. And such a sequence of actions and resulting observations we call an experience, because that describes what an agent experiences as it interacts with its environment. Now we define a goal simply as a way of ranking or defining a preference over possible experiences. So what kind of experiences does the agent want to have, and what kinds of experience does it want to avoid? Now I need to introduce a word which philosophers may be familiar with, but not necessarily everyone else, the word telk. The word telk simply means something that's directed toward an end or a purpose. Now using this word, I want to define the main theoretical contribution of this work, which is what we call a telk state. We define a telk state as a collection of goal-equivalent experiences. So all experiences which are the same with respect to our goal are kind of combined, lumped together into a single telk state. Going back to the example I gave of walking from your home to the park, so if this cloud represents all possible experiences you can imagine of going from your home to the park, a telk state would be a subset, would be a class of experiences that are equivalent with respect to your goal. And different goal would result in different telk states. If, for example, you want to avoid a construction site, so all the paths that go to the construction site will be considered in one telk state. And these telk states are ordered or ranked according to how desirable they are with respect to your goal. Now, what's the use of all of this? So this lets us develop new models of learning in natural and artificial systems that can tell us how agents can affect their experiences through their actions in order to achieve desirable telk states, desirable sets of experiences which they want to undergo. And we define kind of a mathematical computation. I won't go into this, but we define something called the telk distance, which is what the agent is trying to optimize, trying to minimize in order to have more experiences that it wants to enjoy. So learning is defined as this process of minimizing, making this telk distance between your current experience and the experience you want to have smaller. And we have been using this kind of formalism to explain, for example, animal choice behavior, where they need to choose between different possibilities based on sensory stimuli they receive. Another thing I want to say is that this kind of formalism, inspired by Dharmakirti's ideas, can provide a foundation for an alternative view on learning. Current views on learning in cognitive psychology are based on the notion of an agent, a kind of enduring and centralized unit of control that represents, evaluates, and plans in order to achieve its goals. However, I believe that a more flexible and more useful way of thinking about learning is through the perspective of goals instead of the perspective of agents. Goals are much more flexible, much more wide-spanning, and through a formal framework like the telk states framework I just presented to you, we can start develop more rigorous mathematical models of these kinds of flexible learning frameworks. One more thing I want to conclude on is that there is a growing amount of work that's inspired by Buddhist ideas introducing into cognitive science and AI. For example, this work from the Center for the Study of Apparent Selves in Kathmandu, led by Thomas Doctor. And they use the notion of the bodhisattva as a kind of ideal for ultimate intelligence. The idea here is that intelligence is directly related to the extent, the space of the goals that the agent has. So a bodhisattva, because it cares about everything, everywhere, at all times, can also achieve higher level of intelligence. Another work that just recently came out is using ideas from Buddhism to help us solve what's called the alignment problem, how to make sure that these increasingly sophisticated AI systems we are designing have goals that are aligned with the goals that we have or want them to have. So there's very much a lot of interesting and important work happening in these spaces. So just to conclude, I want to give a few takeaways from this talk. We are defining a kind of Buddhist-inspired approach to computational models of learning and goal-directed behavior, which is based on this new notion of telk states defined as goal-equivalent experiences, which provide a kind of Dharmakirtian perspective on purposeful behavior. And they do this by coupling together the descriptive and the evaluative aspects of experience. Telk states capture subjective preferences, so they take an intrinsic rather than extrinsic perspective to learning, and they look at preferences of the particular agent over experience streams or flows of experience, which extends traditional models of AI and cognitive learning, which are usually based on static and localized reward signals. And finally, this kind of model or this kind of work can help bridge Buddhist and modern computational views on concept formation, learning, and purposeful behavior. So with this, I just want to thank my lab mates and my supervisors and colleagues, and thank you very much for your attention.